Welcome to Maths with EJD. In this video, I continue with mathematical induction. As we take the question, you see right there, we want to give the proof for 1 squared plus 2 squared plus 3 squared plus all that up to n squared equals n into n plus 1 into 2n plus 1 all over 6. That is the proof. That is what we need to prove right there. Okay, so as you already know, we have all our steps. Of course, for the sake of it, I just write this. Prove that 1 squared plus 2 squared plus 3 squared plus all that plus n squared equals n into n plus 1 into 2n into 2n plus 1 all over 6, right? So, and that happens for all positive integers, Okay, that's the question. And you know how we go. The first thing we do is to talk about the claim. Okay, what is the claim? The claim is that 1 squared plus 2 squared plus 3 squared plus all that plus n squared is the same thing as n into n plus 1 into 2n plus 1 all over 6. That is the claim. So the next thing we want to do is to take care of the base steps. So let's talk about the base steps. Base step. So at the base step, you use the smallest values, which is usually 1, but I like to go 1, 2, and so on. So at n equals 1 now. So, the left-hand side is a sum, all right? And the right-hand side is a formula, okay? So what do you do with the sum? You add things up. With the formula, you substitute values. So at n equals 1, right? So it means you take just the first value. So that is 1 squared. So the left-hand side is equal to 1, all right? Is equal to 1 squared, which is 1. And the right-hand side would be, the right-hand side is 1 into 1 plus 1 into 2 into 1 plus 1 all over 6. So that is the same thing as 1 into 2 into 2 times 1, 2 plus 1, 3 over 6. So that is 6 over 6, which is also 1. So you see that the left-hand side is equal to the right-hand side, and that is equal to 1. So you can say, therefore, the claim is true. The claim is true for the base step. Okay? So the claim is true for the base step. So we are done with that. So we go now to the inductive hypothesis. And it is at this stage that you assume the claim is true for n equals k. So here you just assume the claim, is true for n equals k. So if you assume the claim is true for n equals k, what do you do now? It means you just have 1 squared plus 2 squared plus 3 squared plus all that plus k squared equals k into k plus 1 into 2k plus 1 all over 6. I mean, for the base step, right, I like to do more than n equals 1, but I mean, I forgot about that. But it's okay. I mean, if you try n equals 2, for instance, it means you just take 1 squared plus 2 squared. That's 5. And then if you put 2 here, you have 2 times 3 times 5. That's 60 divided by 6. I mean, 30 divided by 6, that's 5. So for n equals 2, it's 5 on each side. So it's okay. So not a problem. Of course, but normally what we need is n equals 1, and I've done that already. I just like to do more than that to confirm. But I mean, if you check it, so you see that it's fine. So we have k into k plus 1 into 2k plus 1 all over 6. That's all we can do at this stage. So finally, we move on to the inductive step. That is where we go for the showdown. Inductive step. So so now we say now we need to prove that the claim is true, that the claim is true for n equals k plus 1. And mind you, just like you already know, so for this kind of thing that has a formula, right? How you know your answer is correct at the end of the day is that for every k you have in this expression, you end up having k plus 1. So for this k, you have k plus 1 into, for this k plus 1, now you have k plus 1 into, for this 2k, you have 2 into k plus 1 all over 6. That is how you know that your result is okay. All right. So at the end of the day, every k becomes k plus 1 at this inductive step. So to prove that the claim is true for n equals k plus 1, so look at this. You have 1 squared plus 2 squared plus 3 squared plus all this plus k squared. You know, after k, the next thing is k plus 1 squared. All right. K plus 1 squared. So, and since this is equal to this, right? And if you add k plus 1 squared, it means automatically you have to add k plus 1 squared to the other side. So you have k into k plus 1 into 2k plus 1 all over 6 plus k plus 1 squared. Of course, you can say over 1. So, and once you add this now, you focus on the right-hand side until you get what you need to get, where every k becomes k plus 1. I mean, or every original n that you had becomes k plus 1. So now, and the way to do that is to simplify this. So the LCM here is 6. So 6 and 6 is 1. So 1 times all this is all that. So you have k into k plus 1 into 2k plus 1 plus 1 is 6. So you have 6 into k plus 1 squared. So at first sight, you can already see that k plus 1 is common. So you can take that out. So you have k plus 1 out here into k into 2k plus 1 plus 6 into k plus 1. All right. All over 6. So interestingly, the first k plus 1 is already staring you in the eyes. Okay. So you just need to deal with the other part so you can get what you need to get. Okay, so let's go. We have k plus 1 into, so we need, from all indications, we need to expand the bracket. So we have k times 2k, that's 2k squared, 2k squared. K times 1 is k plus 6k plus 6 times 1, 6. All this over 6. So we keep going and we have k plus 1 into, that's 2k squared plus 7k plus 6. So we need to factorize this, right? You know, plus 6. So to factorize that, what do? You have k squared plus 7k plus 6. To factorize this now, you need two numbers. When you add those two numbers, you get 7. But when you multiply those two numbers, you get when you multiply, you get 6. And those two numbers have to be factors of 6 and 6. So that's 1 and 6. Okay, well, from the look of things, right, it looks like in fact, the stress is not worth it because the two factors you need are already out there for you. You need k and 6. You need 1k and 6k. So there's no point worrying about that. So I just continue with this. So we just need to now factorize what we have now. We have k into 2k plus 1. I'm trying to see what we have to do here. So k squared plus k plus 6k plus 6. Okay. Yeah, my mistake, right? My mistake. This is 2k squared plus 7k plus 6. Sorry. So what we have is 2k squared. Sorry. I was going to forget my quadratic expression there. So you have 2k squared plus 7k plus 6. Sorry. So you need two numbers. When you multiply, you get 2 times 6, which is 12. You know, this and this. But when you add those two numbers, you get 7. And those two numbers should be factors of 12. So from all indications, that should be 3 and 4, all positive. 3 times 4 is 12, and 3 plus 4 is 7. So we can now come back here and have so this now is equal to k plus 1 into 2k squared plus 3k plus 4k, 3 and 4, 3k plus 4k plus 6 all over 6. Don't forget, our goal is to end up getting k plus 1 outside, which you have already. And then you have k plus 2. This is k plus 2, technically. And here you have 2k plus 2. So this is like 2k plus 3. 2k plus 3. We see that. So let's do that. So we have k plus 1 into... So we can factorize now. If you factorize k here, we have k into 2k plus 3 plus here 2 into 2k plus 3. That's for these two now. You take these two, k is common. So all this over 6. So the next thing is to have k plus 1. Then k plus 2 is common. So you have k plus 2. Then interestingly, you have 2k plus 3 all over 6. And what are we expected to get? Don't forget the right-hand side is n into n plus 1 into 2n plus 1 all over 6. And for each of these, right, for every n, we should have k plus 1. So this should be k plus 1 now into k plus 1 plus 1. So for this n, you have k plus 1, then into another 2 into k plus 1 plus 1. All this over 6. This is where we should end up. So that goes that way. All right. So as I embark on this, now let's see. We have this to be equal to k plus 1 already sorted. We have that part. Then k plus 2 is already looking like this. So we can say it's actually k plus 1 plus 1. And then 2k plus 3, this is 2 times k, 2, 2 times 1, 2 plus 1, 3. So we are fine. So this is like 2k plus 2 plus 1. 3 is 2 plus 1 all over 6. Just to make sure it conforms with that picture. So we have k plus 1 into k plus 1 plus 1 like that into, you can factorize 2. There you have 2 into k plus 1 plus 1 all over 6. And then we have got the picture we need. So we have that picture now. So this is where we are going to, and we have arrived there. So you can come and make your final, you can make your conclusion now. So in conclusion, so it means the claim is true now. Since the claim is true for the base step, and the inductive step then it is true. It is true for all positive integers. So that's how that goes. If you have not subscribed, you don't want to forget that. Make sure you subscribe, hit the notification bell, so you can always get alerted when a new video is released. Make comments. You want us to solve a question, or you want me to treat a topic or whatever. Just make your comments and then like, share, and all that, because there are many people that will need this. Thank you for listening. See you in the next video.